the function f of x, y, z equals 2x squared plus 3y squared plus z squared cannot be graphed in 3 dimensions. If our function is of 2 variables, x and y, then we can use z to represent the values of the function, and we get a graph of z versus x and y. If we have a function of 3 variables, we would need a 4th dimension in which to construct our graph, and we don't have one. Now, kind of the best we can do with this is draw our contour surfaces. Okay? F of x, y, z equals c is a contour of this. And f of x, y, z equals c, in case of this function, is a level surface in 3 dimensions, the 3 dimensions x, y, and z. We can see very quickly that this is simply an ellipsoid, right? Okay? If f of x, y, z is set equal to c, we get an ellipsoid, as long as c is bigger than 0, because, of course, if c is less than 0, the sum of squares can't be equal to c. Level surface is an ellipsoid. It's centered at the origin. You can check that out. Set this equal to any number, any positive number. Of course, if you set it equal to 0, you just get the origin, 0, 0, 0. It's the only way these 3 squares can add up to 0. But if you set it to any number bigger than 0, you are going to get an ellipsoid. The semi-axes of the ellipsoid, and you can check this out, or just square root of 2 over 2 times the square root of c, square root of 3 over 3 times the square root of c, and square root of c. And that's respectively on the x, y, and z axes. So for c equals 1, 2, 3, and so forth, what happens to these level surfaces? Well, if c equals 1, let's just look at the semi-axis on the z, because the others will be proportional. If the semi-axis on the z-axis doubles, so do the other 2. Okay, so if c equals 1, this semi-axis and the z-axis will be 1. Okay, we'll intersect the z-axis 1 unit above and 1 unit below the origin. Okay, if c equals 2, then the semi-axis is square root of 2, square root of c, square root of 2, which is like 1.4. 1.414, and then some other figures. Okay, so then if c equals 3, the square root of 3 is 1.732. Okay, so from c equals 1 to c equals 2, you can check my numbers out and write them down. You can see that the semi-axis goes up by about 0.4 units. Between 2 and 3, we go from about 1.4 to 1.7. We only go up by 0.3 units. Okay, from 3 to 4, c, square root of c would go from about 1.732 to 2. Now, 1.732 is a little more than 1.7, so the increase is a little less than the preceding increase, which was around 0.3, actually a little more than 0.3. You can write down what the increases would be. Okay, if we go from c equals 1 to c equals 4, then these semi-axes increase from 1 to 2. To get it to increase from 2 to 3, c would have to go from 4 to 9, because the square root of 9 is 3. Okay? And then to go from 3 to 4, we'd have to go from c equals 9 to c equals 16, and then c equals 16 to c equals 25. You have to go through a wider, through more and more, well, the change in c for a given change in the semi-axis keeps increasing. So what happens is, for every integer change in the semi-axis, we have more and more elliptical, well, ellipsoids. Have trouble with words today. We have more and more ellipsoids between those 2 semi-axes. Okay, so that these things bunch up. Okay, semi-axis 10 and semi-axis 11, we're going to have 11 different values of C. Okay, because semi-axis is 10, C needs to be 100. If it's 11, C needs to be 121. We'll have 11 integer semi-axes. Or 11 semi-axes corresponding to integers C. So, as C increases by integers, we see that the ellipsoids bunch up. I don't want to try to draw that. Okay, looking at another example, f of x, y, z equals 2x squared plus 3y squared minus z. Level surfaces, or would be 2x squared plus 3y squared minus z equals c, and that's easily rearranged to z plus c equals 2x squared plus 3y squared. Now, 2x squared plus 3y squared is an ellipse, and this will be an elliptic paraboloid centered at 0, 0, negative c. Now, if you analyze the paraboloids, you'll see that what you get for different values of c would be a stack of geometrically similar elliptic paraboloids. Okay, each one having the same shape, but centered at a different point on the z-axis. So if c goes from 1 to 2 to 3 to 4, the vertices of these paraboloids will go from the z-axis, negative 1, negative 2, negative 3, negative 4. As c goes up, the vertices will go down. And as c goes into the negative numbers, so it goes 0, negative 1, negative 2, negative 3, negative 4, you'll get elliptic paraboloids with vertices along the positive z-axis. So it's like you can visualize a stack of geometrically similar elliptical paraboloids. So that's fairly easy to see. Just another example. Much more that can be said, but this is how you can look at level surfaces.